Testing. 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 Frank, can you hear me? Frank. Frank. Can you hear me? Thomas? Is it like loud or? Testing. This is my voice on TV. Cool. All right.
Oh, is this the new mic we bought?
Yeah.
Wow.
Thanks to a very supportive CEO.
I actually said yes to this. Can you hear it?
Yeah.
Yeah? Ja. Wat? Als ze niet op de foto willen. Als ze niet op de foto willen. Misschien moet ik daarmee beginnen, want dat ga ik gegarandeerd vergeten. Ja. This is really the fastest crowd I've ever seen. Can you hear me? Because I only hear myself, so I don't hear anything over the speakers. Because Adele asked me to start talking in the microphone so you would all come and sit down, but you're too fast. This is really... I didn't even start talking, you're already sitting here. My name is Frank. I'm from Trifork. I'm the CEO since January. So it's my honor to actually welcome you into to our building, or at least part of it is our building. For the ones that don't know Trifork, we're building innovative software, mainly using the JVM. But we also focus on machine learning and on IoT, although the IoT part is mainly in our Eindhoven office. Where I'm seeing Jonah is sitting there, and he's really fond of it too. So that's part of our job. So we like to do cool stuff using new technologies, and we also like to tell the world about it. And that's also why we host a lot of these meetups. We organize a lot of them ourselves. And it's really part of the Trifork family, and that's also why GOTO is actually a Trifork brand. So it's part of the bigger Trifork family, and GOTO is actually doing these meetups as well. But they also organize public trainings where you can actually see some examples here, and obviously they offer a really big conference. But I think Adele wants to introduce GOTO herself. Yeah. So before that, I have to ask one thing. In the back is Karen. Karen is doing a lot of pictures of these events. So if anyone objects of having their picture on a website, then please raise your hand, and then we'll put a nice smiley on top of you or something. Well, the photos now are from the back of your head, so it's probably not recognizable anyway. But if you have an objection, please tell Karen. I will make sure that we respect that. Okay, then I think it's up to Adele. Adele is...
Hello. Thank you for... thanks, Frank, firstly, for the... providing the venue tonight. You know, with the Dutch weather, we might had to have risked standing outside in the rain without a venue. So thank you to Frank for providing the venue tonight, and to Trifork, of course. So I'm just speaking here on behalf of GOTO tonight. I mean, this is a GOTO night. The reason we have these meetups is as a bit of a prelude to our GOTO conference, which is in June. So the GOTO conference is a full stack software developer conference for developers by developers. I've got some selected tracks up there. We've got an IoT track called Brave New Smart World. We've got some pretty cool speakers in that track. Practical microservices, human factor, also some others like DevOps, machine learning, etc., etc. Also there you can see some selected workshops, ML for developers and Java 9. So I do encourage you to check it out. Go to ams.nl. Our speakers are usually of a very, very high quality, such as the speakers that you will see tonight. We are an invite-only conference. We've been doing this for 20 years. We are in 4 cities throughout the world. The first conference was actually started by our current CEO, Jörn. A developer himself was dissatisfied with the conferences he was going to, so decided to build his own conference, invited a heap of people he thought were cool, and a fair chunk of them said yes, and he went, now I have to build a conference. So that's how we started, and we like to keep that sort of DNA going. But that's enough from me. If you want to check it out, you will. One of you will be winning a ticket to the GOTO conference tonight, as long as you don't leave early. So if you would like to possibly win that ticket, please see my lovely colleague Karin over there, and she will collect your details, and you will go into the draw to win. So what I will do now is pass you over to our first speaker, Johan. check the sound.
Does the sound work? Nothing? Or okay.
And you can all hear him, right? Yeah.
For whatever reason, it displays my taskbar at the bottom. That's not what it should do. Okay. I can't quickly find it. So let's for now continue with the bar at the bottom, unfortunately. So I'm going to talk about Amazon's Alexa for voice recognition. Whom of you have already used Alexa at home, maybe, or played around with it? Quite some people already, nice. Which is surprising as it's not really available in the Netherlands officially, but you can still play with it. So my name is Johan Janssen. I work for a company called InfoSupport, so I don't work for Amazon. I don't try to sell you Amazon devices. For me, it's just an example of a voice recognition technology, which I quite like, but you could do it probably with stuff from Google or from Apple as well. But I like the Amazon stuff, which I will also explain in the slides. So it will be about voice recognition. And this will basically be the content of the next 45 minutes. If you have any questions, please feel free to interrupt me and I'll try and answer them directly. You don't have to wait until the end. That's probably easier for you and for me. So first I wanted to start with a bit about what's the Internet of Things and how does home automation fit into it. So Internet of Things, you probably have heard of it. It's quite popular buzzword nowadays. And most of the times it involves some kind of chip, some kind of computer, something with a wire, some kind of a network connection. But also sometimes people call things IoT just for a marketing perspective to sell stuff. I was at a conference in an IoT track and somebody had a beautiful light which basically showed the humidity and the temperature in the room and some other environment variables. And they did that with a color. So instead of seeing digits, they displayed colors. So for people who can't read digits or they're having problems for whatever reason with digits, they would have a light which would display how the temperature and everything in the room was. And I quite liked the idea. It looked quite nice. But towards the end of the talk, somebody asked, okay, but it's Internet of Things. How do you connect it to the Internet? Oh, it's not yet connected. Okay. Oh, and basically the light is randomly changing colors. So basically we listened for an hour to an LED changing colors. So Internet of Things, be careful, don't believe everything which they put on the package. A term that I found quite well describing is the infrastructure of the information society. And so with IoT, basically you have all kinds of devices connecting with each other, having lots of data flowing around, and you can do lots of things with it. And so how does home automation fit in? Who of you have automated your home? Partly, not so much yet. Probably after this session you can get started. So most of the people probably control their home with a smartphone. That's probably the most popular way to do it. And you can control the lights, the temperature, the radio, things like that. But there are some other things that we can control. I got this from a colleague of mine and I found it quite interesting. So basically my colleague had 2 rooms and 1 television. a living room and a bedroom. He's from Belgium, so we could make a lot of jokes about that because we do that in the Netherlands. But I found it quite a nice idea. The Neo robot likes it as well. So I also asked him, if you get hot weather, can you make it spin quicker? Because then you have a fan. But he didn't try it out yet. But he could control this from work while being in the Netherlands. And this was at his home. So he completely automated this part. I quite liked it. But I think in the end it would have been cheaper to buy 2 televisions. Exactly. It's cooler to do it like this. And that's part of IoT. Yeah. So for me, home automation is like a subset of IoT. Everything you do in and around your house with a bit of technology, having fun or doing a bit more serious stuff. But home automation, it has some challenges if you do it in the current way. I mean, if you control it with your smartphone and you need to charge it, then you cannot use it to control your home. And probably with this phone, you cannot do anything anyway. And smartphones have the habit of breaking. So then you cannot control your lights anymore when you get home, or turn on the television, or do whatever you want to do. But one of the most important things is if you're having a discussion while having dinner or lunch with your family, maybe it only happens at my place, but we sometimes have that discussion and then we don't agree. And I could pick up my smartphone and try to Google it or look on Wikipedia, but it's a bit rude to play with your smartphone during dinner, and most importantly, your dinner gets cold, so it's not really convenient. Or if you're relaxing on a chair, you can have some issues grabbing your smartphone. So for me, smartphones are a little bit like Batman. They were cool in the past, but they had their best days. So for me, I like home automation, like Amazon's Alexa, which uses... Oh, okay, should disable it.
I don't know that.
So this is an Echo Dot, which you can use for the voice recognition service of Amazon. It contains a few microphones, a speaker, but that's basically it. So all the commands are being sent to the cloud and to Alexa service. So Alexa is not a woman. It's basically AI running in the cloud. If it was a woman, she would be quite busy because they already sold like hundreds of thousands of these devices. So it's a cloud environment which basically listens. So the only thing the device does is, if I say the wake word like Alexa, then it will start recording and it will transmit everything to the cloud, and the cloud will basically process everything. So this device is quite dumb. It simply transmits stuff. In the cloud, they try to interpret everything and try to give you a proper response. And that's all automated, basically. So I can, for instance, say, Alexa, play TuneIn Radio.
Getting the last tune-in station you listen to. Dance FM UAE.
Alexa, Wikipedia, Java programming language.
Java is a set of computer software and specifications developed by Sun Microsystems,
Alexa,
which was late.
Stop. Alexa, stop. So it basically reads the entire Wikipedia page, which is probably boring if I would have continued with it. But what you could see here is that I could play sound with it and basically ask other instructions in between or other questions in between, and it would pause the sound for a minute, and after it's done it will simply continue playing sounds again. So I use some free service to play sounds, but you can connect it to Spotify or anything you want, basically. And you can use it, for instance, to read stuff from Wikipedia, but you can also ask Alexa all kinds of interesting questions, such as, where can I hide a dead body?
I'm not sure.
Alexa, where can I hide a dead body?
I'd take the body to the police.
So, something quite useful around Amsterdam, because sometimes people get shot here and then you know what to do. But it has more relevant information as well, like, Alexa, what's the weather in Amsterdam?
In Amsterdam, Netherlands, it's 13 degrees Celsius with partly sunny skies. Tonight, You can look for clouds and showers.
Alexa, stop. And the nice thing is, so now I use it on the Echo Dot, which doesn't have an interface, but I could also use it on my television or on a tablet, and then it would display the information as well. So if I go to the website quickly, so this information that you, oh, wait a second. First pause this one. So the information that was being told by Alexa is also visible in a nice graphical overview. So if you have your tablet or if you're using an Amazon device on your television, you get this as well. So if you ask for Wikipedia, I think it's down here as well. It will also show the article. So here is the article, and apparently it thinks that Java is some kind of music or something like that. But it's not only like telling things, it will also show things if you have the proper devices. So when this stuff came out, I was like, yeah, it looks cool, but I mean, it works out of the box. So what's interesting if you're a developer and like to play around with a bit of hardware and a bit of software? I mean, it works. You don't, at least I don't like that. I like to play with stuff. So I wasn't excited in the beginning, but then basically they released instructions with which you could build your own Echo Dot. So basically, this is a Raspberry Pi at the back. I can show it a bit better here. So Raspberry Pi, touchscreen. Touchscreen isn't mandatory, but I thought it was cool, so I added it. Microphone and a speaker. So that's basically doing the same as this thing. And at that time, this one wasn't released yet. They only had a more expensive Echo Dot. So this was also better value for money, and it allowed me to play around with installing the Alexa stuff on my Raspberry Pi. And it is all open source, so I could look at the sources. They have a Java client for it, which allows you to basically do a lot of things that you want to do. I replaced that microphone, by the way, with this one. It's a lot smaller and practical and works quite well. So if you want to try this yourself, you can easily go to the website and try it out. I can also give a demo. So let's see. I'm basically now connected to my Raspberry Pi. And I use it now with a button. So I have to press a button before it will start recording. So if I ask it a question like, where is Chuck Norris?
If Chuck Norris wants you to know where he is, he'll find you. If he doesn't, you won't know until it's too late.
So basically this works the same, but I have to press a button. They have also services available that you can do this without pressing a button, so that it works on keywords like Alexa for the Echo Dot. But those services you have to pay for, and you get like a trial for a month. So I opted to not install them because then I had to configure my trials every time. And in the beginning, only this was available, but they kept on improving it, and now you can do almost the same as with the official Echo Dot. Yeah, so if you compare it a bit price-wise, like Raspberry Pi solution was quite a bit more expensive in my setup than the new Echo Dot. So nowadays, if you do it for a price perspective, then probably buying an Echo Dot is a lot cheaper. So if you want to have things working quickly, buy an Echo Dot. If you want to spend as least money as possible, buy an Echo Dot. If you want to have flexibility and play around, then I mean build it yourself. You can control everything you want. So some people are concerned that if I say something, that Alexa will always send it to the cloud. So Amazon says that it will only start recording after I say Alexa. But some people are concerned that they might send everything to the cloud. Some researchers tried it with network sniffers and they said no, it's not sending things, but it's a sensitive discussion. If you have an open source application, you can of course control yourself what you're sending. So it might be interesting for people who are privacy concerned. And you have all the flexibility that you want. You can do whatever you want with it. Although I wouldn't advise this for most people. So what if we want to use Alexa for home automation? Because I think that's a nice way of using it. And we're using OpenHub for it, which I'll explain later. But first I'll show a short movie of it.
Trigger, open the sunscreen.
Sending that to IFT.
So basically you see the sunscreen at the top coming down now. And this is the OpenHub web interface where you can see everything. It's in Dutch, but probably
Amazon.
quite explainable. It's lights,
Trigger,
temperature,
close
and
the
stuff like that.
sunscreen.
Sending that to IFT.
And if you pay attention to it with the lights, you can see that it also updates the status. So if with Alexa
Amazon.
the lights are changed,
Turn
it will
on
update
all
the
the
interface. So over here.
Okay.
Hey Amazon, turn off all the lights.
Okay.
Hey Amazon, turn on the dinner table light.
Okay.
So here you see where my colleague who used OpenUp, he had it already set up, and OpenUp is basically a web interface, or you can use it as an app on your smartphone, on your tablet. So you control it with either of those devices. And he had it coupled already to sunscreen, to the lights and everything. So he was like, okay, can I somehow connect Alexa to my OpenHub setup, and then I'm done, basically. So I will show you how we've done that. One thing you might have noticed is my colleague who made the movie, he says, hey Amazon, instead of hey Alexa. You can pick 3 words, basically, 3 different type of wake words. The reason he picked a computer or Amazon was because his neighbor kid was called Alexa, and it's kind of strange if you start shouting Alexa stop. So unfortunately you cannot pick any wake word you want. You have to pick one out of the 3 they have available, but it works. So what's OpenUp? OpenUp is basically an open source Java project which you can use to create a nice interface which is usable by non-tech people as well to control the home. And it looks a bit like this. So lights, temperature, sound, temperature, and LED strip, heating in the bedrooms. It's really nice. It looks quite intuitive. I quite like it. And it basically works on a ladder like this. You have different items. So an item is, for instance, the sunscreen. And I can send commands to it, like on or off, or open it for a certain percentage, or open it a little bit, or close it a little bit. But the cool thing is, I also receive status updates. So for instance, if I connect this to my lights, and I also have a hardware switch to control my lights, then it will also notice if the lights are on or off. So it will update it in the web interface if I use hardware separate from OpenHub to control anything in my home. So that's quite nice. You can use both the smart solution and the more dumb solution and get the status updates. So there are basically 2 interfaces, the app interface, the web interface. You connect the different devices. Every device has an item basically, and they have a rule. This is the first edition of OpenHub, so this you need to be a bit tech savvy to know how this works. It's a bit of configuration. I could do it quite well, but I can understand that if you're not a developer or into tech, this will take you quite a bit of work to get it up and running. But luckily they created a newer version which is more click and play, connecting things together instead of writing those rules yourself. So that's really nice. So I couldn't bring the sunscreens because it's a bit big. So I brought something else, which is a smart plug. And what a smart plug basically does is it will put power on or off. So you can put this on your television or on your lights or whatever, and you can then control through an API if it should be on or off. So now it's on, green light, and now it's off. So let's see if we can do that. So it's.
How did you do it with the sunscreen? So how does the scrunchie, how can you manage it?
Good question. How does the sunscreen work? I don't know the exact details because it's from my colleague, but it had some I think it had a remote device already, which you could use to basically open it and close it. So basically he called the software that was already available to make it open and close. Nowadays, for lots of sunscreens and things like that, they sell them already with IoT applications in mind, so you can connect to it automatically. I think that was how he did it, yeah. So I have the device on the bottom. I cannot really lift it because then all the cables will fall out. But you can see here if my power is connected or not. So now it's connected. And let's try if we can shut it off. Alexa, trigger switch off.
Sending that to IFT.
Now it's off. Alexa, trigger switch on.
Sending that to IFT.
And if I look at the web interface, so now it's on. And if I say, Alexa, trigger switch off. Alexa, trigger switch off.
Sending that to IFT.
So it's also updated in the interface.
Can you just click it now?
I can also click it, yeah, of course. So now it's on. I can combine different ways of controlling it, and it's automatically updated. So this is a really simple example, but you could do this with everything that's home automated.
Could you put the Alexa power on the switch so you can self-destruct?
Yeah, I can definitely do that. Yeah. But it's difficult then to turn it on. Or I need another Alexa device to turn it on or something like that. But it's possible, yeah, definitely. So how did we build this? We used a service for this called If This Then That. It's basically a website which allows you to combine different elements. Basically, if something happens, make sure something else happens. That's If This Then That. Really like the name already says. So I created two different things. If you say Alexa, trigger switch off, then send a command. And if you say Alexa, trigger switch on, then send a command. So just to quickly show you how easy it is. So you just register for free. It's a free service. So I have a switch off command. Oh wait, it's at the configuration is at the top. So basically if I say the phrase switch off, then it will react to it and it will send a command to the TP-Link switch item, which is an item in my OpenUp configuration. And it will send the off command to the TP-Link switch item. And that's everything I have to do. So most of the configuration is in OpenUp already. So I can use this to couple Alexa to OpenUp, but I can use it for all kinds of different things. I can also say, Alexa, trigger SMS.
Sending that to IFT.
Should send me an SMS now. So I now get an SMS. I can put in whichever text I want to add. So basically I can couple it with everything. I also made a solution where Alexa has to-do lists. But the to-do list, if you want to know the contents of it, you have to ask Alexa what's on the to-do list, and it will start speaking. But I mean, if it's a shopping list, then you don't have Alexa with you. So what I did was basically every time I added something to my to-do list with Alexa, it would automatically send me an email with the complete to-do list, so that I would always have the to-do list available. And I did that simply by creating an IFT applet for it. So it has lots of very useful applications. Yeah, so how does it work? We have the Echo Dot. It connects to the Alexa environment. And then with IFT, we go to the My OpenUp environment, because you need My OpenUp to make OpenUp available on the internet, basically. So this is also an online service. It connects to OpenUp on my Raspberry Pi. And my Raspberry Pi connects to my smart plug. When I demoed this at a conference, actually the developer of OpenUp watched the talk, and he was like, "Oh, how can you do this live?" And I was like, "How? Do you don't trust your own service?" And I was like, "Yeah, I trust it." But actually, most of the time it works quite well. Of course, if you're on a busy network using Wi-Fi, it can be a little bit slower, but at home it's nearly real time, basically. Demo, we already saw the demo basically, so let's skip that one. So in case you have functionality that you want to add to your Alexa, you could use if, but you could also use so-called skills. And skills, I don't do that. Wasn't me. Skills is basically a way of adding functionality to Alexa. You can compare it to apps on your smartphone. So there is a kind of a skill store for Alexa where you can download existing skills. But you can also create your own skills. And you can basically do anything with skills. Whatever you can think of, you can create a skill for it. And actually, there is already an Alexa HA skill which allows you to couple Alexa directly to OpenHub. So now I don't have to use IFT anymore. I could connect to it automatically. But I like the IFT setup as a demo, so I kept that in there. If you want to create skills within Alexa, you basically have two different types, custom skills and smart home skills. I will show some of the code in a minute, but first I think it's helpful if you know a bit how the terminology works. So if I say Alexa ask tell, then I name the invocation name, which is basically the name of my skill. And what I say next to it is the utterance, that's basically the command that's being sent to the skill. So that's how Alexa works for terminology. One extra step is that all the utterances are coupled to intents. So one intent can have multiple utterances, and every utterance belongs to one intent, basically. So if you look at an example for it, which is so I have one intent, really easy. My first intent, not really anything special there. And I have one utterance for the intent called hello. This class basically contains almost nothing except for a simple call to this class. So we will go to this class immediately. And what happens here is I override a few methods, which basically I implement a speechlet, which is provided by Amazon, and I can override whatever I want. So in this case, I override the on intent, and that basically checks which intents I use. So for my first intent, I call a certain method. If I would have multiple intents, I could have called different methods for every intent. So what I did there is I call this method, and I create a card. And if you remember from the web interface, so let's do it for this one. Alexa, ask first to say hello. It's running in AWS Lambda, which is basically
my first skill, which is built at Java 1.
Which is basically a serverless solution, but the disadvantage of serverless solutions is that they spin down if you don't send any requests for a while. So then if you ask a request after a certain while, it takes a bit to power up. So if I ask it again now, Alexa, ask first to say hello.
Hello from my first skill,
so now
which
it's
is built at
almost
Java
instant.
1.
So the information you're seeing here, like normal response I don't care about, hello from my first skill, blah, blah, blah. That's all written in the card. So I create a card with the information. It's optional. So I could remove all the card information, but then I wouldn't see anything in the interface about what happened. And the most important part here is the plain text output speech, where I use the text here. And then in the end, I send the text back, and Alexa will simply talk to me and tell whatever text I put there. So that's everything basically from recognizing that I say hello with the sample utterance to basically giving a proper response. So I didn't have to do any difficult coding for it. It's all plain and fairly simple code. And if I create these skills, I can create them in Java, but also in Node or in Python or a bunch of other languages. And I can deploy them in AWS Lambda, which Amazon, of course, likes because it's from them. It has an advantage for you as well, because like the first 1 million requests are for free every month. And for home usage, yeah, normally you don't have that many requests. So I basically use it for free. But I could also run it on a local web service or a web service running in the cloud and simply manage it myself. That's also a possibility. So how does it work?
So one question. What
Yes.
then runs in the cloud and what not? When you say you run this service locally, but it's still like that the actual, let's say, voice recognition, the actual translation,
Good.
is still done in the cloud? Is that
Good
correct?
question. The voice recognition and the processing, it's always done in the cloud. But I could run my skill locally. But then basically it would do the voice processing in the cloud and call my skill and then probably send a response back to the cloud again. So you always need the cloud. Without it, you cannot do anything useful with it.
And when it's running locally, is Alexa connecting to the... So can I have it closed up or should it be open to the internet? Because the Alexa service, like it's not the device that's connecting to local.
We can close it up, but I will show in a minute.
Okay.
So hopefully in the next few slides it will answer your question, and else
Great.
ask it again, please. So if we want to use this, we could simply upload the jar in AWS Lambda, which you do manually. You browse to the website, upload the jar file, and then there is an Amazon developer portal. And here I create a skill and say, okay, this skill should be coupled to this application running in AWS Lambda. And then through the normal Alexa services, I can use it on my Echo Dot. So I have to do two things. I have to deploy an application or my skill over here. But I also need to create the skill in the developer portal to make it available to my Alexa account. Yes. So basically this is AWS Lambda, and I could simply say create new function. I don't want Node, I want Java. So you already see there's a bunch of other languages available. I can select some security roles. Should be a basic one over here somewhere. Create function name, of course. Test. Create function. And then basically I can say, okay, couple it to Alexa and upload my zip or jar file. And that's quite nice if you only do it once, but if you want to do like continuous delivery and you want to make small updates to your application, it's quite cumbersome to have to go to the website over and over again. So I don't really like this setup, and we'll see a solution for it in a second. First, a little bit about privacy, which also partly relates to your question. So normally, if I deploy my application in AWS Lambda, I can make sure my skill can reach the application. The problem, however, is if you don't use proper security, every other skill can use it as well. So that's something you probably don't want, because if it's a paid service, then you have to pay for the requests of other people. You can fix that quite easily. In the application I've shown you, I've had this code, which basically disables all security. It's better to change it and make it into this, where you define the ID of the skill in your AWS Lambda application, so that only that skill can access your AWS Lambda application. So this is a way of basically making sure you're the only one that can connect to your AWS Lambda application. And to make it a bit more advanced, what we set up was an automated deployment to AWS Lambda. So no longer using the web interface, I simply wanted to do it with commands. And fortunately, there was already a Maven plugin available and one for Jenkins as well, who could both do this. But it required a little bit of extra setup. We needed to create an S3 bucket in Amazon, which is basically storage from Amazon. And we needed to create an AWS role, which would be able to deploy the artifact from the S3 bucket into AWS Lambda. But those two steps, that's basically something you do once, and you can use it every time for all the skills that you create. So it's a one-time action. And then I can simply run a Maven command, and my skill will automatically be deployed. So if it's a new skill, it will create a new AWS Lambda function. If it's an existing skill, it will update the existing AWS Lambda application. So for me, this worked a lot nicer. So if we demo that, So what I did was I made a copy of my first skill basically, and we rename a few things because I don't want to type the entire application. So it's a bit of Maven configuration, but most of it you can easily borrow from the internet. And here, this is the configuration for the Lambda plugin, which will deploy my functionality in AWS Lambda. I can specify a few things like the function name, but also the memory that should be reserved for it. And let's add something as a response as well so that we can see if it is working. So we say now that it's built at GOTO night. And let's see, I've created a script to deploy it, which basically contains my AWS credentials to connect to AWS, because of course, yeah, you need to somehow make a secure connection to it. It will start deploying. Let's see, it should be visible here quite quickly. Go to skill. So you see it's deployed quite quickly. I have a skill with all the configuration already. I don't have to do the configuration through the web interface, and it's over here. One thing I need then is the ARN, which basically is the unique URL for every skill. If you know this, you could use my skill for free, basically. And then I have to go to the Alexa developer portal to create a skill. So let's call it the GOTO skill. Yes. I just want to create a custom skill. Create skill. So before I forget, first enter the endpoint. So you can see here that I can also use HTTPS if you want to connect to your own web server or another cloud vendor where you run your application. Invocation, so the name of the skill, basically we call it computer, doesn't really matter. Intent, so we have, let's quickly look, I think it was my first intent. My first intent and an utterance called hello. First intent. Hello. And I can say build model. It takes a bit to configure everything now and make sure that it works. So these are basically the only steps that I need to do to make my AWS Lambda application available as a skill for my Alexa device. I continue with a few slides and then we'll come back because we have to wait and sometimes it takes a little bit longer. So a bit about possibilities, like what you've seen was fairly simple. We had the hello utterance. But you could use variables as utterances as well. So you could basically respond to anything people say. And you can make fairly complicated things with it. So I could also, for my skill, I always have to say the name of my skill and then the utterance. And if I want to call it again, I have to say the name again and the utterance. But I can also create like a session. So if I say, Alexa, ask second. Again, it has to warm up because...
Welcome to my second skill.
Random number.
33.
Random number.
49.
Stop.
See you next time.
So basically I was in a session with my skill. Only the first time I have to call the skill and then I can easily have a conversation with it without having to say all the extra stuff. So basically anything you can think of or anything you can program in a Java language or in all of the available languages you could do with Alexa. It's fairly big what you can do with it. So the session conversation, I handle unknown input. So for me the input was known, I used hello, but I could also make a skill that would basically tell me what big event happened on a certain day. And then I simply say the day and it will return the event. That's also possible. You can do whatever you want. Program in any language you want. One thing I found quite curious was how you would test this. Of course, I could write some unit tests for it, but I mean, they could all pass and still my Alexa skill couldn't work because any issue somewhere in the infrastructure, in the setup of my skill or anything. So I thought the best way to test Alexa skill is by using Alexa itself and make it talk. Ask tester to start.
Alexa asks second to say hello. Hello from my second skill. Alexa asks second. Welcome to my second skill. Stop. See you next time. Testing the skill was successful. No issues were found.
So if I would change it quickly, I could say, okay, I expect they say something with the GOTO, the first and the third. Run a deploy. So now basically what I'm doing is I test the skill which is running on my Echo Dot, and I run the skill tester on this also Amazon device, which is a tablet. And basically they communicate with each other to test if everything is working. So if we try it again, ask tester to start. Also after the first deployment, of course, it's never used, so it takes a bit.
Hello from my second skill. Alexa asks second. Welcome to my second skill. Stop. See you next time. The following requests gave an unexpected answer, 0 expected.
So here I can exactly see what went wrong in the different questions. So this way I can program everything I want, basically.
Is the Alexa tester again from Amazon, or is it?
I've written this myself. It's only a few lines of code, basically. It's nothing really fancy or anything. It was just a way for me of testing out how things work. So what I simply do is I loop over a list of questions and I keep asking them and I record the responses. So it's basically one class with the request and the responses and then looping over it. So let's see, where's the code? So most of the code is in here and in a few more methods, so it's fairly simple Java code. One thing I didn't mention yet, there are some default intents, like the stop intent, which I can use to simply say stop, and then it will stop the session. And Amazon already provides it, so I don't have to build any logic for it. I can use the stop intent from Amazon, and then in my code, I can say, okay, if the stop intent is being sent, then I can simply send a message like see you next time. So there are some built-in intents for help, stop, and functionalities like that as well.
Do you have two instances of Alexa, or just one to deal with the speaking and
I have two devices that talk to one Alexa service. So there's one Alexa service running in the cloud, basically, or maybe they scale it with the load balancer in front of it, I don't know, but for us, it's simply one service that you talk to, yeah. So if you want to build this yourself, there are some excellent examples in Java available. I created some examples as well with the AWS Lambda integration. I think that works a lot nicer than uploading the zips manually. So if you want a new feature, I would recommend to see if there is an existing skill which already does it. If not, try to integrate it with IFT, because that's also fairly easy. And if that's also not possible, create a custom skill. Another good reason to create a custom skill is, of course, to have some fun and program around. Some disadvantages of Alexa: it's still a bit in a learning curve, so you see that some languages are not supported, some things don't work. For instance, region-based, it's only supporting English and German, and it doesn't support Dutch. So it's still getting better and better. If you have an accent, you get ignored. So it's not like Google. I mean, if you ask a question on Google and you basically type rubberish, you most of the time get the correct answer magically. Alexa will simply not respond. So that's something to get used to. Privacy, like I mentioned, some people are concerned that Amazon is recording too much stuff and learns too much about you. Another issue is security. The device listens to anyone. If it's your kid, your parent, it doesn't matter. So if your kid learns to say, Alexa, order lost pizza again, which is actually a feature of one of the pizza vendors, you will get an extra pizza again. And maybe if your kid says it 10 times, you get 10 pizzas. So that's quite a risk, because it's coupled to your credit card, and anyone that walks into your room can basically do with it what he wants. So there is a joke, like if you want to know if there is an Alexa device in the room, simply walk into the room and say, Alexa, order 10 tons of rice. But I think it has quite some advantages. It's not only new and cool, but it's actually quite useful. You can do quite some useful things with it, and you actually get used to it quite quickly. My colleague brought this home, and his wife was like, "Ah, no, another gadget. Why does it have to be in the room? Put it in some other room." But after like 2 weeks, he had to return it to me, and his wife asked, "Hey, can we buy one as well? Because it's really easy." So it's really easy to accept it and start working with it if you're not technical as well. I think that's a nice way. So I think smartphones are partly that, because some of the functionality you can do with devices like this in a better way. So conclusion, yeah, I really like the Amazon setup because it's easy to integrate with other devices. You can program your own features basically, and you quickly get used to it. Of course, you have to learn a few commands because else it won't respond, but as soon as you know those commands, you can do anything you want. And of course, it's fun as a developer to easily build something that has speech recognition and does whatever you want. I really like that, and it's almost unbelievable how simple they made it for you. I've worked with speech recognition in the past where I did things myself, and it's also almost impossible to do, so I'm glad Amazon has a better solution for it. So basically that was it. Any questions?
Well, I have to actually. How did you, in your investigation or like thinking with this device, did you also compare it with the other devices like from Google and Apple and see what came up with the list of differences in between, advantages, disadvantages?
Yeah, good question. So the question was, did I do a comparison with, for instance, the solution from Google and from Apple? Actually, I didn't do it because I know that some people already did it and there is research available on the internet. So it felt for me a bit like reinventing the wheel to try and make the same comparison. Next to that, I think that at least the one from Apple isn't selling really well. I heard they cancelled some of the orders. So I think the Amazon device has way largest market share, like 70–80% or something like that. And I like the fact that it's really affordable, so it's like only $50. And most of the other solutions are quite a bit more expensive. So I didn't compare them, but I think there are some obvious and some less obvious advantages of all of them. But I would recommend Googling for it because there's quite some information available for it. Again, another question?
Yeah. And the other question is, your testing mechanism works because, well, the way I see it works because Alexa is responding verbally to the commands that you're asking.
Yeah.
Right. Now, what if you're asking Alexa to trigger something like to turn off the TV or turn off this switch or something? How would you test that it actually did turn on or off that thing that you asked it?
That's a good question. So the question is, if Alexa doesn't reply, but Alexa sends a command, for instance, to turn on a television, how do we check that it works? So you could do one check to return, if Alexa returns OK, then at least you know the command is received. And what you maybe could do is make somehow a listener on the device that you're calling. So if you're calling, for instance, an Open Hub instance, which will trigger the lights, I could of course listen which request Open Hub receives and also interpret them. But I agree with you, that's a bit more difficult than simply parsing some text that Alexa responds. Other questions? And
can Alexa rap?
Alexa, can you rap?
My name is Alexa, and I'm here to say, I'm the baddest AI in the cloud today. Your responses are fast, but mine are faster. Sucker speech engines. They call me master.
I didn't pay him, but it was a very good question. You had another question? Or?
Well, actually, you asked something earlier about how if you can have this entire setup off the cloud and have it like in a contained.
Okay, the question is, can you have this set up in a container environment without the cloud? No, because all the processing is being done in the Amazon cloud. So the only thing that's happening locally is that it listens for the wake word. So in my case, it listens for Alexa. And everything I say after Alexa will be sent to the cloud without any processing, basically. It does a little bit of processing because there are 7 microphones in it, and it will do noise cancellation and noise reduction features. But then everything is sent to the cloud for processing.
Yeah, but when it's processing it, after that, if you want to host your skills locally, is the device connecting to it, or is it the cloud when it interprets it? The Amazon service is actually connecting to your local server.
The skill you create connects to your local server then. So Amazon will do the processing.
So the Amazon developers, when you create the skill, it's where it's trying to connect. So
exactly.
So if you have that skill running locally, you still have to open that server to the world.
Exactly, yeah. So the skills are all made available on the cloud. So you make your skill available to the cloud, and then you can connect it to your own private machine. Exactly, yeah.
So at the end, it's probably safer or more secure to keep it in the cloud, because then you have to manage your own security on the server.
Depends, yeah. Then you trust that the cloud vendor has proper security.
Yeah.
Okay, thank you all. Have a good evening.
So we have a 10-minute break, and then we'll have our second talk. And if you haven't had a chat with my lovely colleague Karen yet, and you want to win that ticket, this is your last chance. Okay, I'd ask you to take your seat now. We've got an awesome second talk lined up. One of our speakers has driven all the way from Munich today, up at 6 o'clock, and the other one caught a plane. See if you can guess. Maybe I'll give you a chocolate. Right, so I'll hand that one over to you.
Okay, you can hear us? Yeah, that would be awesome.
It's on.
Okay, ladies and gentlemen, welcome here at the GOTO Night Amsterdam to our talk, Telepresence Robotics with Now and Kinect. And yeah, before we start with our talk, we want to introduce ourselves. So Thomas.
So my name is Thomas Endres. I studied computer sciences in Munich, and after studying, I joined TNG Technology Consulting, and after that we started creating nice showcases, some of which you will see today.
Right. My name is Martin Förtsch. I studied computer sciences as well. And yeah, we want to talk about a really crazy prototype project about which is in the context of telepresence robotics and stuff. And yeah, where it all began, our crazy prototypes.
Back in the year 2013, we were controlling quadrocopters using bare hands. So we tried to control them without any keyboard or controller or anything, just using our hands and not even touching anything. And you could control it using this for left and right, forward, backward, up, down, and also controlling the yaw like this. And with this, people were able to steer the quadrocopter within minutes, I would say.
Yeah. So it's like Minority Report for drones or quadrocopters. Yeah.
After the first few crashes,
yes,
it worked.
Awesome. So yeah, in the year 2014 and 15, we developed an augmented reality glass with which you can see the world through the eyes of a Terminator. So it happened that I wake up in the morning and I thought, oh my God, I want to see the world like Arnold Schwarzenegger. And yeah, we just built a prototype to realize that. So we took some virtual reality glasses, something like this, an Oculus Rift, and we attached 2 cameras on it to see the world in 3D, just normal. And we added a 3D camera on it. And with this construction, we saw something like this. So the face was highlighted, like Terminator style, with 78 landmark points in the face. We had some kind of emotion detection because we are nerds. We don't recognize any emotion, so we need some technical help. And we also were able to measure the heart rate.
So and here's our first question.
And this is our first question. How can we measure the heart rate just by looking to a person without touching him?
Skin color.
Okay. The skin color was right. Perfect, awesome. Yeah. So he won a chocolate, and we still have 2 left. So
There will
be
more
prepared. There will
questions.
be some more questions. So how can you actually measure the heart rate just by looking to a person? Yeah, it's the skin color. How does it work? With each and every heart bump, yeah, round about 15 grams of blood. Roundabout. Some people more, other people less. They get pressed into the head, and this will result in a very tiny color change, which a 3D camera or a really good full HD camera actually can recognize this color difference. And with this you can just calculate the heart rate. It's maybe not that precise like a real medical device, but it's still good enough.
Yeah. So if you run up and down the stairs, it will
Right.
see that you did something.
Yeah. Okay. But what is this all about today? What we have here? As you already may recognize, we get inspired by science fiction movies. So we just steal we get influenced by ideas from science fiction movies, and here in this case James Cameron's Avatar. So the idea here was we wanted to slip into the role of another object. So here in this case, Captain Jack Sully, who is disabled, he's not able to walk, slips into the role of a so-called Navi. This is this blue tall guy. And when he is in the role of this Navi, he actually can enjoy the environment from the perspective of this native from the moon Pandora. So he can hear, see, and feel everything. So actually he's somehow able to walk again. Yeah, somehow. So the idea is clear. We wanted to have the same experience, out-of-body experience. And how do we realize that? So we have no Navi. For us it was clear we need an object, a physical object, maybe a robot, a humanoid robot. Then we need virtual reality glasses where we can get a video signal streamed in from the perspective of the object we want to control. Yeah? And as we don't like to touch keyboards, joysticks, and any other buttons, we made a decision. We want to use a 3D camera, which is doing some kind of full body tracking, and this gets applied to the physical object we want to remote control. Okay, so far so good, Thomas?
Yeah, so who are we, by the way? So we, that's not just the 2 of us, but we have a complete team behind us. Normally, our ideas start at a so-called winter retreat. This is one day where we go into the Alps, and then we try to hack a first prototype within the first day. Of course, it's not as perfect as as you can see it right now. So we have additional days, the so-called tech days, where we come into the office and try to improve our software, our hardware that we built here. And then in total, these people have worked on the prototype since.
Yeah, so actually 10% of our working time we are allowed to do such things. Yeah. Okay, so now let's go to the agenda.
First we'll have an introduction, then we'll have a look into the history of telepresence and telerobotics. Yep. Then next one we'll have the cool part, namely we'll have some live demo, we'll show you how to control the robot, and so on and so on.
Yeah, so some live coding is
yes.
There as well.
Yeah. Absolutely. And then we'll have a look at the fields of applications, followed by a conclusion.
Yeah. Right. So let's start with this picture. So this is a picture from Frederick Remington, the smoke signal. We want to tell you about the backgrounds about telepresence robotics. So we want to overcome human barriers. One human barrier is communication over long distances. Yeah, and this is actually what the natives here are doing. They are using smoke signals to communicate with other tribes, to warn there are some cowboys or whatever. And there are several barriers you want to overcome. For example, you want to be in dangerous places without harming yourself. So this is the case when you are sending a robot instead of a human to put some trash away in a power plant where a disaster beyond all expectations happened. Other barriers are, for example, matter or scale. Let's talk about scale. Surgery robots. So normally a surgeon can only make an operation with a precision of, it depends, centimeters, millimeters, and such surgeon robot like the Da Vinci is able to be much more precise and accurate. Yeah.
Yeah, when it comes to telepresence robotics, we're talking about two different terms. The first one would be teleoperation. Teleoperation basically just means that you control something remotely. So you control a system by not being physically in touch with it. So in this case, we have the Carpio robot in front, and this robot is controlled by the exoskeleton that you see in the back. And we are doing pretty much the same, but with different technologies in our showcase. Then there's a second term, and this is telepresence. And telepresence is basically just means that you feel like you are somewhere else. And we have these classical telepresence robots that you can see in the slide. These normally come with a camera, but also with a display and with microphone and speakers, so that the other person can see you, but you can also interact with this person. And there are different kinds of robots that you can use for this purpose.
Yeah. Right. So now it's getting a bit, we go a bit into the theory. So this is a typical slide you can see in the book, Springer Book of Robotics. And it's about multimodal telepresence, because this is what we are actually doing here. So we have two sides. We have the operator side and the remote side. On the operator side, the human operator is generating position and forces data. So normally this is done using a joystick, a keyboard, or whatever. And this data gets sent over a communication channel by your choice, so if it is Wi-Fi or radio or whatever, to the teleoperator. The teleoperator can manipulate the environment on the remote side. Using sensors, he can recognize those changes in the environment, yes? And these changes, they get sent back. This is the feedback data. It can be visual, haptic, or acoustic. This gets sent back over the communication channel, and then you can use some different kinds of displays. For example, you use headphones to get some acoustic feedback data, or screens for visual data, and so on and so on. And this is how this demo, of course, works as well. So now let's have a look into the history of telepresence robotics.
Yeah, and when it comes to the history, this is the first example that we found. So Ralph Mosher, back in the year 1958, he created a device which was really enormous. So you can see the first part of the device here. This is just the controller. So he has these massive things on his hand, and with this he can actually control a robot. So in the foreground you see the two hands. He controls with it, and whenever he moves his hands, or the devices on his hands, then the robot moves the same way. And this can be useful, at first for scaring kids, of course, for spinning hula hoop wheels, and for some useful cases as well. So you could, this was actually intended as a proof of concept for handling dangerous substances. So you could fill one Erlenmeyer tube into another, and so on and so on.
Yeah. Right. So this was 1958. Now let's jump to into 1986. So some bad things happened. It was the disaster beyond all expectations in Chernobyl. And actually you can see some engineers here on the roof of the power plant, and you can see 500 Röntgens. I think that's round about 4.7 sievert or something like that. Actually it means if you are there on the rooftop, on the roof, if you are there for 30 seconds or 1 minute, you get really, really sick, and you will die within the next 30 days. So they wanted to put all the trash away, because they wanted to build this sarcophage. And this was, as I already said, very dangerous. And here they are using a moon rover from the German Democratic Republic. And they prepared it, so they used some mercury, so that it will not break immediately, but still the radiation was so high that also remote controlling this moon rover wasn't possible. and it broke within minutes. So they sent those liquidators, the bio robots, onto the roof, and of course they were really, they were radiated, and not a good thing. So this is a case where you want to send robots, but in this case it didn't work.
Actually, in the meantime, there was a robot sent to Fukushima, and this worked a little bit better than the one.
Because it was shielded with water.
Yes.
Yeah. Okay. 2001. Yeah. Dr. Jacques Morisco, he made a surgery in Europe, and he operated old women on the hips, and she was in, I think, New York, so in the US, and they only had internet connection of 10 megabit, and they were still able to make this surgery a success. And they, of course, they had fight with delays and everything, but it was successful. The women survived.
What a success.
It was a success. I'm sorry for that. Okay, so these were some examples from the history about telepresence robotics and stuff, and now we want to talk about this little guy, the Now robot we are using for our telepresence prototype.
Yeah, as you can see, the Now robot is a cute little robot that you can control. It has in total, I think, 26 degrees of freedom, and it is 50 centimeters in height. It was built since 2006 by then it was Aldebaran Robotics, but nowadays it was bought by SoftBank Robotics, so they are building it now. And as you can see, its main feature is cuteness.
But it didn't look
It
like
didn't
this
look
from the
like
beginning?
this from the beginning. So if you see pictures from the year 2005, this was the first prototype that was actually there. There were just some motors, some cables, some electronics, and yeah, everything was kept together by duct tape somehow.
So from which year is this model?
This is the current model. I think we bought it in 2014? 15.
Yeah. 14. We bought it in 2015, but it's the Evolution 5 from 2014.
Yeah. So this robot is used for the RoboCup. So it's the standard model. So if you have a look to YouTube for soccer games with those Now guys, yeah, you can enjoy watching those robots falling down.
Actually, they are quite good.
But yeah, they're better than expected. Okay.
Pay for it.
Sorry?
How much you have to pay for it?
How much do you have to pay for it? 6,000 euros roundabout. It depends.
Yeah, so that's what.
But
that's what
if you want to play around with the Now robot, sometimes universities or user groups or something like that, they have access to a Now robot on conferences. Very often you have the chance to play with them, so it's not a problem. And yeah, we want to show you, of course, how to program the robot. It's really easy, I think. So let's have a look to the Now features. I want to tell you about the most important ones. So we have 4 microphones. Why? Why do we have 4 microphones? Why not only 1?
Can determine your position, I guess.
Sorry?
Can determine your position.
Yes, right. I would say this is another chocolate.
Another chocolate for you.
Okay. Yeah, it's about we want to point out where the audio source is coming from, so that the okay.
More
you want to
chocolate.
ask more questions. So you want to identify the source of the audio so that you can react in a way you want to. We have speakers. I don't ask why we have speakers, because that's quite clear. You want to communicate with the Now, so he wants to talk with you over the speakers. We have 2 cameras implemented. So one is here and one is here. Okay. We have a battery so that it can run standalone for 4 to 5 hours. It depends on what you are doing. And Wi-Fi connection is the typical connection you are using, but Ethernet is available as well. And we have a sonar so that you can identify objects which are just moving into your direction or something like that. So it's perfectly well suited for RoboCup because you can identify a ball when it moves into your direction or something like that. Okay, so let's talk about predefined poses of the Now robot.
Yeah. So there are a few poses. Yeah, you already have the most important one.
The most important one is lying back, that's right.
So as you can see, the robot is currently in one of the poses. So this is the crouch pose. But you can also press his belly button and then he will stand up. We will do this in a few seconds. And there are things like he can do this gesture, but most of the time where poses are really important is if it's in this position. This is normally not taken voluntarily, as you probably guessed. But the good thing is that the poses can be, so he can move from one pose to another. So if he's lying on his back, he can get up on himself, so you don't have to put him up. It's not working all the time, but it's working quite good.
If you don't attach such heavy hardware and wires, like in this case, it works quite often.
Yeah.
Or I would say it works always.
Yeah, and if it doesn't work, he'll just try again.
Yeah, okay. Okay, so far this is predefined poses. And now we want to discuss how to move those different angles of the robot, how to say, freely. So in fact we have 26 degrees of freedom. And if you have a look to the skeleton of the Now robot, you will see that it is somehow copied from the human skeleton. So if you have a look to the hip, for example, I can move my hips in all directions, in all 3 degrees of freedom, and this is the case for the Now as well. Or for the knee, for example, it's the same. And yeah, these abbreviations are used, these are the names of the ankles, and we want to use that to control the robot now freely with a live coding demo, right?
Yeah.
Okay.
But before we can do this, we need to prepare a bit.
Yes, right. So
that's why I copied one of the pages of the manual into this presentation, and here you can see how you can control the different degrees of freedom. So for example, you have the shoulder roll, which is this degree of freedom, and which can move from minus 18 degrees to 76 degrees. Stop it.
Alexa, stop it.
And then you have different degrees of freedom as well. So what we want to do now is we want to put him from this comfortable position in which he is currently standing to this position.
Yeah, right. So this position, you have 20 seconds to comply. Okay, from which movie is this?
Terminator.
Wrong. Give me your chocolate. Oh, you don't have one.
RoboCup. We had it.
Oh, right. It was RoboCop. Not RoboCup. RoboCop. That's important. Did he say RoboCop?
I think he said so.
Okay.
Let's just interpret it this way.
Okay. So let's continue.
What we want to do now, normally I would say we want the people to decide.
Yeah, right. So you have the possibility now to decide which programming language we want to use. So, which one do we want to use?
Java.
Okay.
There's also
C#.
C#, okay. Anyone Python? Really? Not?
Python.
Okay, but who is for Java? Okay, and Python? Ah, okay. So we make Java. It's okay.
Yeah, okay. It has
to be honest, the difference between the Java thing and the Python thing is not that big. It's only the boilerplate.
We'll have a look at this in a second. Okay, so what do you have to do to really program the robot? So here in this example you can see it. At first you create an application. And this application gets 2 arguments. So the first one is the URL of the robot. So as we already know, it is connected via Wi-Fi or Ethernet. In either case it gets assigned an IP, and with that you can connect to it. And then you have a port, which is normally 1969, I think. And then you can connect to the robot, and then you start the application. Martin?
Yeah?
Hmm?
Oh!
Also a nice picture, but
yeah,
not related.
No, but I have to take my editor window because I have to type and I have to and you have to tell the story.
Yeah, and then yeah. Okay, now now it's working, and then you can create so-called proxies. So these proxies can do some action on the robot actually. So there are a few proxies that you can use. The text-to-speech proxy is pretty obvious, so you can let the robot speak. You can also play some audio files with it, and the posture proxy is the one we were already talking about. So if you want to go from one posture to another one, this is the proxy you will use. And the motion proxy is for now the most important one, the one we will be using right now. And with this, you can actually move freely. So every degree of freedom can be moved freely.
Yeah.
Okay. So let's have a look at the code itself. So this is actually live coding. So Martin will demonstrate that.
System out, print line, hello world. So
okay. So it's really live coding.
It's really live.
And Martin can type really fast, so
okay.
we will see. At first,
make jokes. Just make your talk.
At first, we want to specify which different degrees of freedom we want to use. So for the left hand, for example, it's the shoulder roll. This one, we want to have the elbow roll, I think, and we want the shoulder pitch so that we can also move it forward. Okay, so let's define that.
I did it.
And then we'll do this for the same for the right hand, but there we just need to replace the L with the R at the beginning.
Yeah.
And then
remember the slide with the skeleton.
Yeah, this is from the skeleton slide. And then we want to define for each of the angles, we want to define a value into which we want to put it. So we'll do this again by creating a list. And as you can see in this list, the 2.0f now relates to the left shoulder roll, the next one to the left elbow roll, and so on and so on.
And those numbers, were taken out of the documentation slide we already saw.
Yeah,
for the left,
just the radians,
but it's for the right arm.
It's just the radians value of the angles that you want to put them in.
Yeah. Okay.
And then we do the same, of course, for the right hand. This is somehow a bit different because they need to be symmetrical, which changes the direction, which changes the signs a bit. And then we want to use the motion proxy. We put into the method set angles, we put, of course, the joints, then the angles, and then the speed at which it has to be moved. So 0.0f would mean no movement at all, and 1 would mean the fastest movement possible.
Yeah, but this is of course a bit dangerous because if the movements are too fast, it's most likely that the robot will fall. Yeah, he loses his balance. You have to be careful.
Yeah, and we do the same, of course, for the right hand. And that's about everything you need to put the joints of the robot into a specific position.
If a quick question. If you command his arm like to move or his leg,
yeah,
does he try to maintain balance if you do it like slow enough or
no.
Not at all?
No, that's also why we do not control the legs directly, because yeah, he would lose balance immediately. So if he falls, that's completely your fault.
Okay, so I hope we are prepared right now. So I just added a speech proxy say you have 20 seconds to comply. And now this is a live demo and I hope it will work. Sometimes it needs a few seconds but it's, till it gets compiled. But I would say let's try it. So it's executing.
Let's see. As always, live demos.
No problem.
Take
Just
some time and
don't be so nervous. I just will execute it again.
You have 20 seconds to comply.
Yeah. Awesome. Awesome. That's really cool, isn't it? Let's have a look to the Now robot right now. We have the Now robot in this position, and as you maybe recognize, he's really, how to say, stiff. Yeah. So the stiffness of this robot is just 1 right now. This is this is the name for this parameter. So that he will remain in this position. So there is power on the motors, so that the stiffness can be 1, so that it's really, you know, hard to move. But there is a problem. After, let's say, 10 minutes maybe, or 20 minutes, he starts to complain. Hey, my motors are going too hot. So it's a good idea to use another command. It was motion proxy dot rest, right?
Rest, yeah.
Rest. And then the voltage will get removed from the motors, and it will remain in a relaxed state. Okay, we try it.
So Martin will call the command directly after he said this. You have 20 seconds to comply. Also, what you can see here is that the set angles command is asynchronous, so it does not wait for the first command to finish. There are also some synchronous commands available, so that you can also program it in a way that only the commands are executed consecutively.
Okay, let's try. Executing.
That's easier with.
You have to tell. Yeah, you have to tell him twice all the stuff. Let's see. So actually, it was.
You have 20 seconds to comply.
And now 2 seconds and then rest. Yeah. Awesome. And now you can see, stiffness is gone. And now we can remain him the rest of the talk. Okay. So far so good. And now. We can switch the slide, move over, and now the demonstration of our prototype, right?
So let's move to the last demo.
Now it's getting really interesting. When we first gave this talk in the Netherlands, I think it was at IoT Tech Days. Is that right? Last year. Last year, somebody called this stuff tech porn, and in fact, it is tech porn because all the things we are using are inside the airplane in the flight case, and except the robot itself. And yeah, we want to show you how it works and how it was realized. So now what you can see here is Thomas wearing an Oculus Rift. I help you. Okay, with those 2 cameras. Why?
I don't have a signal.
Oh.
Toggle it maybe?
We don't have a signal for you? Oh, why? Okay, well, what's the problem?
Okay.
1 moment. Okay, that's 1 moment. So it's all unplugged right now. I will plug it in again. Awesome.
We have a signal.
Okay, we have a signal. So Thomas is online actually. And he's wearing an Oculus Rift, development kit version 2, and he has 2 cameras on the front of the Oculus. The reason for this is that he can still see the environment as usual without the VR headset. And Thomas, may I ask you to place yourself in front of the Kinect camera?
I'm already there.
This is the Kinect camera, and maybe you go 1 step back, maybe. Yeah,
am I still in the video?
Yeah, everything is fine.
Okay.
Yeah, you're still online. And now we will transfer Thomas' consciousness into the robot. And this is done with a gesture with the left arm. So take your smartphones right now. With the left arm you will make a circle gesture clockwise. And if everything goes right, now he is inside the robot. And I can show you. Because if so this is what you can see, what Thomas is actually seeing. So it's not it's this one. You can Thomas, please move down your arms. So you can see.
Well,
so now Thomas can't see anything. Yeah. Okay. So does anybody have a pen or something like that? Maybe I have one. 1 moment. I look like the mad scientist here. So okay, so please open your right arm. Yeah, fingers. Now close the hand. Close the hand. Okay, and now throw it away. Oh, let's try it again. Let's try it again. It's a very small pen, so it's not fair. So open your hands, please, in direction of the Kinect, please.
Where is it?
Okay, right. Close. Okay, close. Okay, and now throw it away.
If your hands are too high for the Kinect, I guess.
Yeah,
I think so.
Yeah. Okay. So, but Thomas is also able to work. If his legs are recognized by the Kinect, we can try it. So, Thomas, please make a walking gesture. Yeah, just continue. Okay, awesome. Stop, please. Stop. Okay. Awesome. What we already told you is that the movements of the legs. Yeah, just wink to the audience. Just wink to the audience, Thomas. Say goodbye.
Bye bye.
Okay, stop. Okay, normally we have a red button and we can stop the whole process. It's what is it called?
Emergency
stop. But I forgot it in Munich, so
I'm back.
Yeah. Okay, so Thomas is back in reality, and thank you. Okay, so I'm a bit. Yeah, right. We have to switch back to the presentation laptop.
Whoa, thanks.
Wow, after 2 beers, it's still a good reaction. Okay, so one moment. Here we are. But now, yeah, okay, awesome. So far so good, and now we want to tell you how we realized this project. So you are now prepared. You know how to move the ankles, the degrees of freedom freely. You can do it on your own, technically, if you have a Now robot. So this is our multimodal telepresence image slide from the beginning, and how we implemented it. So we have on the operator side, not a haptic display, because no joystick, nothing. It's the 3D camera sensor, a Kinect. But you can use the IntelRealSense camera as well, so we have different kinds of implementation used here. The communication channel is everything over Wi-Fi. But today we have some Ethernet connection as well.
Yeah, I don't know why do you put it there, but
I don't know.
That's okay.
It's okay. Actually, the whole demo can be operated without any wires, because it has a battery included, the Now robot, and it's enough to power all the hardware we attach to the Now robot. So the teleoperator is our Now. The Now has different sensors. Yeah, like those goggles. The question is, why do we use this 3D printed glasses here with the stereo camera?
Why
anyone an idea?
Just use the normal camera.
Why didn't we use the 2 cameras which are in the Now robot?
Because they're not the right direction.
Okay, chocolate. So the answer is correct. If you want have a stereoscopic view of your environment, it's not a good idea if you have cameras which are vertically aligned. You need them horizontally aligned.
You could still look this direction.
You know the Minions? Yeah. I think there are ones with such vertical aligned eyes, but I don't know if they are happy with this view. Anyway, so we are using those self-printed housing and the stereo camera from Alibaba. Also this web shop there, yeah, Chinese web shop there. And we have some feedback sensors, other ones. For example, if you touch the head of the Now robot, Thomas can feel this on his head because we have a vibration motor implemented in the headset. So if you just touch the Now robot, hey, are you fine? Are you okay? He actually will feel that.
That's our haptic feedback.
This is the haptic feedback in this case, right? So yeah, you can. There are many ideas you can think about how to display different feedback data. How would you feedback data with radiation?
That would be a difficult
maybe
one.
Temperature. I don't know.
Okay, so let's have a look at the architecture. This is a bit more complicated because it combines both hardware and software. So I'll start with the hardware right now. Of course, we have the Now robot and we have a laptop. To this laptop, we have two different kinds of hardware attached to it. First of all, the Kinect camera, of course, and the Oculus Rift. On the Now robot, we have a Raspberry Pi, which is attached to the back of the Now, so you can see it here. So this is our Raspberry, and this one is connected to the cameras in the front of the Now. Yeah, and everything is connected. Okay. So everything is connected using an Intel IoT gateway. So yeah, he's also listening quite extensively. And yeah, from a software perspective, it looks a bit different. So we have, first of all, the Kinect steerer. So the Kinect camera signal is taken and then processed and into positional data of the different joints. This is sent over to the Intel IoT gateway, where it is then sent over to the Now controller, which is implemented in a Docker container within this Intel IoT gateway, where it is sent via the Now Key SDK, which we already saw in this presentation. And with that, you can control the Now.
Yeah, and yeah, all this stuff here is you can find it in the flight case. So yeah, the Intel IoT gateway, the router board, and everything. Okay. So now let's discuss what can you do with such a prototype. Of course, you can't send a Now robot into a power plant where a disaster beyond all expectations happened. But yeah, maybe you can use those ideas to apply them to big robots. Yeah, there is a question.
Can I ask about the architecture? Can we go back?
Yes, of course. Can we go back? Yeah. Oh, wow.
I mean, you communicate through the IoT gateway, but I mean, we saw that you can actually go over the Wi-Fi and
it is
the SDK directly. So I wonder why you don't do that here.
It is done actually via Wi-Fi. The IoT gateway is just the man in the middle, so it's the central communication point, and from there, for example, the Now is controlled over Wi-Fi. So
without it, you can't directly talk to the SDK.
You could also directly talk to the SDK, but in this case, we wanted to have an independence from the laptop itself. So this is just a central point that we put in the middle for controlling everything. It is actually important for one thing, and this is the vibration controller, because
I was wondering, it's because you have additional devices.
Yeah, the vibration controller is a bit different because it is not connected to the laptop at all. It is just connected to the IoT gateway, and from there it is
so the vibration controller is the thing with the head.
Yeah, this one actually. So it is sitting right here. And yeah, you can.
So without that, you wouldn't need the gateway, right?
There are a few more things. So, for example, the emergency stop button, which we unfortunately forgot to bring with us, is also not connected to the laptop. So there is a bit of peripheral devices that is placed around these things. You can also have a look at the suitcase afterwards, and within the suitcase there are a bit more things which would not be possible hadn't we used some central device for controlling, for aggregating all the data.
Okay. Okay, so what if we use such prototypes, such a software on large robots? This is the idea. And yeah, we ask ourselves, yeah, which robots are actually existing, large robots? So yeah, of course there is the Honda Asimo, which is built since 2000. And I think around about 60 to 70 units are existing all over the world, and there are non-commercial, so you can't buy them. And yeah, this robot is, yeah, he can walk those stairs, that's quite perfect, but he has to be prepared in a very exact way to walk those steps. In the first generations it was the case, and if there was a slight difference, something like this happened, or something like that happened, and yeah, of course that's not much fun. And yeah, let's have a look to a robot which is just prepared to hold its balance in a really good way. So this is the Atlas robot. By the way, this is not the newest video. I think it's 1.5 years old. In the meantime, there were new ones. So this robot has a LiDAR on his head and many sensors, but this robot is prepared with a very intelligent software to hold its balance. Okay, it looks drunk, right? But at least it holds its balance. Also, if it's slippery, if it's wet, and if it's icy. Also, if you give him a kick in the ass, he will most likely hold its balance. With one exception, like here, because it was just too hard, but no problem for Atlas, because he's still able to stand up. Maybe it looks not that elegant like the Now robot when he stands up, but anyway, it's a really cool project showing what robots can do nowadays. In the newest video of the Atlas, he is doing, what is the English word? A backflip. A backflip. And it looks really scary, I can tell you.
But
really.
Let's have a look at the non-promotional video.
Of course, the non-promotional video looks sometimes a bit different.
This is not as scary anymore.
Yeah. Okay. So don't fear artificial intelligence and self-learning programs when it comes to holding the balance. Okay. Yeah, actually the Atlas robot attended the DARPA challenge, and we want to have a look on this later on.
Yeah,
but at first, code and technology.
Yeah, we'll have a look at the different technologies that were used here. First one would be the Kinect. This is the Kinect version 1. So it's actually the second version, but it was used for the Xbox One. That's why they had to term it like that. It is suitable for recognizing skeletons. So it can track up to 6 skeletons at the same time, and it detects 35 points on each of the skeletons. As you can see, these relate somehow to the joints that we saw on the robot. So if you, for example, take this point, and this point, you can directly calculate the angle which the shoulder, which the elbow roll, for example, needs to be put in. Okay, we have actually a demo of this. So if Martin is standing in front of the Kinect, you see this is an HTML5 demo.
So this is you.
Doesn't it look natural? So here you can see the different joints.
Yeah. So this is an HTML5 presentation, so it's no Flash or whatever you think. It's just it's HTML with CSS, and
it's using WebSockets here to communicate to the browser. We also have other cameras. So this demo can also be used with the Intel RealSense camera.
Yeah, and now it's getting interesting because we are in the Netherlands, and I want to know what our word for this camera means in Dutch.
Oh yeah.
Okay.
So in German it's called eierlegende Wollmilchsau.
Eierlegende Wollmilchsau in Germany, it's what you call in English an all-rounder.
Yeah, it's the mammal which gives milk but also lays eggs.
Yeah, it's an egg-laying wool milk pig, but how do you call it in the Netherlands?
Do we have a word for that?
Yeah.
Sorry?
Vogelbekdier.
Vogelbekdier. Vogelbekdier, okay. Hey, I can speak Dutch. That's nice.
That's not for chocolate.
Now you need to pronounce it.
After a few beers.
Okay, so okay, let's talk about the eierlegende Wollmilchsau. So this is actually there is a creative printed on the housing, but there is Intel technology inside. So Intel is building 3D cameras as well. we see the F200 SR300, and I have such a camera in my laptop integrated. And why is it an all-rounder camera? Because it can do face recognition, as we already told you about the Terminator vision with the 78 landmark points. It has a skeleton model for the hands.
But it can also do things like object tracking, and it can do speech synthesis, speech recognition, and so on and so on. So you can do lots of things with the SDK there. And one is the one we want to show you, and this is
face detection, or face tracking, face detection.
Face contour detection.
I have to remove.
Actually, I think that Martin's browser is a bit slow, because normally it would be a bit more.
I could refresh it, but.
Yeah,
then maybe
but you can see it. It looks like an old Kraftwerk video, and you can see that the 78 landmark points, and it detects, for example, the nose. It also can detect the eyebrows, and with that you can create different showcases. So, for example, the Terminator vision is one of them, but you could also create games where you have to fish for candy or something like that.
Catching table tennis balls. Something like that. Okay, let's go. Yeah, Intel announced in August 2016 dates at the IDF the Intel Euclid, and the idea behind this camera is that you have a USB-sized 3D camera where everything is included inside the in this device. So you have the hardware power, the CPU power inside the stick, and also a battery to use it for your own IoT projects. For example, there are a lot of projects where people are controlling segways autonomously with the Kinect. The problem is that the Kinect weighs around about 1.5 kilograms, and this Euclid is only a few grams, so it's maybe a nice device, but we didn't try it. Yeah.
Also out there is the new generation of cameras, so the ones we were using for this project are already old, I would say, so in 2017 or 18, I don't know, somewhere around the turn of the year, the new cameras came out. So there are two new cameras which you can use. They are called 415 and 435.
Whatever.
And you can actually buy them right now.
Yeah.
Okay.
So, a few words to the Oculus Rift.
Yeah, the Oculus Rift. So the one we are using right now is still the development kit version 2. We use that because we had one in stock actually, but there is a consumer version out there which we nowadays already also have, and this one is a bit better than the one we have right now. It has a resolution of 2500 cross 1600 pixels, and the delay is pretty good. So yeah, it can be used for high-end virtual reality games as well. When it comes to the Oculus, we have different effects which come into place if you have such a normal picture that you normally see whenever
maybe you remember the demo when you saw the stuff Thomas was seeing inside the Oculus. It looked like a so-called barrel distortion.
Yeah, you can see it here as well. We don't have any chocolate left.
No, so we have to don't ask questions, just tell.
So we have to tell you right away. So this is something that the lenses which are built into the Oculus, yeah, they are
very close to the display.
Yeah, very close to the display, and they have a bit of a distortion. And this distortion can be eliminated if you calculate it in. And this is what causes this barrel distortion. There's also a second effect, which you can see if you have a look at these edges. So they are not clear edges, but you have something that is called chromatic aberration. And this is what happens if you have lenses in place which are very close to the eye, and then you see these hard edges not as hard edges. And again, if you calculate that in, you can eliminate this effect. And this is what you see right here.
Awesome. So now let's talk about the challenges. So one challenge was we had the limited bandwidth. So imagine when we are sending video signals, command signals to the Now robot and everything. We have a large bandwidth we are using.
The problem is also that we are not just sending video data, but we want to have no delay. So this is why we are using MJPEG as a video format. And MJPEG, as you probably might know, is quite bandwidth intensive, because we are just putting JPEG after JPEG after JPEG after JPEG. And with this we get a video bandwidth of about 40 to 50 megabits per second. And with this we came to some limitations. So one limitation was that at the same time you could not receive the control commands, for example. Yeah. And that's why we built a custom router board. In this suitcase, which you have not seen right now, there are actually two different antennas. So this is just a router board with one card, but we have one with which sends out two Wi-Fi signals. One is just for the commands and all the other stuff, and the second one is just for the stream. And that's how we overcame this challenge.
We can switch this slide because limited CPU power just by
this was
powerful laptop
at the beginning of 2016.
So fields of application, as I already told you, if you want to overcome the barrier of scale, buy a Da Vinci robot, a surgeon robot, and in this case you can see that the surgeon is controlling the robot very precisely, so with a precision of millimeters, maybe less. And Da Vinci is built since 2000, and when we held this talk in Boston, actually there was a guy in the audience, and he told us that his father was operated by this machine. And why? Because he had a cancer which was very, very how do you say, dangerous, or you know what I mean? Aggressive, right? That's perfect. He was really aggressive, and they had to remove this cancer very precisely, because if they do just a little bit wrong, it will spread. And it was successful. That was a good story, right? And another field of application, you can use telerobotic systems, like here the Carpio again. Here it is controlled with an active exoskeleton. So the exoskeleton here has motors included, so that you actually can carry 3 baskets of beer. So you can carry 100 kilograms without a problem. And but here in this case, it is used just to remote control this Carpio. Does it make sense? I don't know. A 3D camera would be also pretty well. But anyway, let's continue.
Yeah, you can also use it for distance learning, and this is one of the classical telepresence system that you might have seen in Big Bang Theory, series like this. And there they are using it to communicate over long distances, but this is actually a use case when it comes to people who have immune deficiency. Like in this case, Lyndon Beatty, he cannot attend class because he has such a rare case. And in his case, he can now take part in the social life within class just by using this system. And back in the year 2016, there were 60 people around the world.
60 people all over the world using this for distance learning.
Yeah.
Okay.
Yeah, and there's also, this is just again one classical example. So in this case, you can see a robot arm which is using off-the-shelf hardware, in this case an iPad. And with this, you cannot just attend a meeting, but you can also walk around, look around.
We just wanted to show that because it was crowdfunded, but there are nowadays so many systems which are crowdfunded. Okay, let's go. We have no time.
Okay.
We can stop right now, but if you want, we have a few more slides when it comes to the differentiation about telepresence robotics and autonomous stuff. Do we want to continue? Let's say 5 minutes? Yeah? Okay, you're fine with that. Okay. So let's talk about differentiation about telepresence robotics when it comes to exploring the Mars. So the question, I don't ask them because we don't have chocolate, is why not using telepresence robotics to explore the Mars? I think the answer is quite clear, because we have a limited signal speed. So in our case, when you place the robot on the other side of the Earth, and you send your control signals to the other side and you wait for the answer, then you have 4,000 kilometers of way. Sorry?
40.
40, I said it. I said 30? Okay, I mean 40, of course. And so 40,000 kilometers, and what does it mean? Yeah, this means that we have 0.1 seconds of signal delay. In fact, I think it's a bit more if you ask a physicist. Physicist.
It's late.
Yeah. Okay. 8-hour drive from Munich, you know. And if you have the same with with the moon, you have a delay of 2.6 seconds. So in fact, what does it mean? So 0.1 second means it's a big bottle of beer. 2.6 seconds, it's maybe half. It's five beer bottles of beer, maybe. Delay, you know. When it comes to the Mars, I think you are in a coma state or something like that. When we wrote the talk 1.5 years or 2 years before, it was the Mars was next to the Earth, so the delay was 8.5 minutes.
Which is pretty close.
Yeah, and today I think it's much more, because the Mars is far away than when the talk was written. So how can we solve such a problem? So how telepresence robotics, of course, makes no sense on the Mars. But what can you do instead? Yeah, you can maybe use some kind of semi-autonomous systems. So you train your system, your robot, or you implement subroutines like drain a hole there and take an example, put it away, like here in this case. So you give the Mars rover Curiosity just a path where to drive, and then to execute some actions which are prepared on Earth or which are sent as functions or procedures to the rover later on. And now this brings us to the DARPA challenge.
Yeah, and this is
because there we want to they train the robots to do something like that.
Yeah, this is from the year 2015, and this is the winner. It's Hubo, it's called Hubo, and this is a time-lapse video. This is important to know because it was not really that fast. So he just got some orders from and like open that gorge, drill a hole into that wall, open the door, and leave again.
So it's not directly remote controlled or something like that. It's just send a command, control the gorge, drain a hole there, drill a hole there.
Drill a hole there. And then get out of the building again.
So get out.
And as you can see, now it's taking actually some time to think. This is about a minute or so.
He's doing different things. He's measuring the stairs, and he's some kind of thinking.
So unlike the Asimo who was just falling down the stairs, this one is really measuring and trying to get a path out.
The stairs you just saw were the reason why the Atlas robot were only the second place, because he just stopped at the stairs. So Hubu was the winner. Yeah, so far so good. That's it about differentiation about telepresence robotics and semi-autonomous systems. And now to the conclusion.
Yeah.
So we wanted to show, if it is possible to implement a telepresence robotic system in a short period of time.
And it definitely is. You can see it standing here, and it's just using off-the-shelf hardware, so no special hardware except for the glasses, which were 3D printed, were used in this showcase. This is definitely possible, but it's not always what you want to use. So in some cases you want to have semi-autonomous systems.
May I
tell
something?
No.
After 8 hours of work with 8 software consultants of TNG, we were able to control the Now robot with the Kinect. And that is, I think, quite impressive. The other stuff, of course, like video transmission and stuff, was much more complicated, especially when it comes to delays and so on and so on. Yeah, you want to add something?
No, I'm finished.
You're finished?
I'm
Yeah,
fine.
you look like this. Okay, yeah, so I think we both are finished, and yeah, if you have any questions, now it's the time.
First step.
Thank you, thank you. Yeah, please.
I've got two small ones for you. Well, the first one is, can you make it lay back and then stand up so we can see that one?
You can try it?
Yes, we can just put
We
it.
just remove the hardware and then we try it. Okay? Okay.
You can actually just.
So why do I remove all the stuff? Because the weight point is different with all this hardware as it is implemented in the OS, and yeah, so I just remove it.
He could still stand up, but it would look even more silly.
Yeah, actually it looks silly, so just try it, okay?
Yeah, you can
now-
just put him.
Now,
Just lay him back.
okay.
Wait a second, I think I'll have to stop this application.
Yeah, I think if I push the button twice, it should work, right?
Actually, it should, but try it now.
Okay. Okay. Okay, let's try it again. One moment. Okay, let's try. Hey, what's wrong?
Stand up, please.
Too late.
Yeah.
Hey? Okay, one moment. Okay. Mach mal nichts.
Nee, es ist aus.
One moment. Okay, let's try it again. Last try. Okay. Now, I'm sorry for that. Please.
I think he. Yeah. Maybe. Maybe we can help him a bit. No.
Okay. All right. But we can try something different. What if we go back to the programming slide and say just
Let's try it.
Do we want to try it? Then let's go.
Posture proxy.
Yeah, I know. Where is it? Okay, that's.
Here it is. And now I think all we have to do is just remove everything here.
And then
go to posture crouch.
Posture proxy. Ah, here, zack. Okay. I hope it works.
I think he's trying actually. Refuse it.
What's wrong with him?
I think he's
maybe the
old.
Are the metal? Whoa! Be careful.
He's actually trying.
Maybe the motors are what? I don't know. Because of standing the whole talk here, I don't know.
Let's see. Okay, let's try again. I think actually maybe he's really his motors are just.
Be careful. Yeah.
Now you can put in lying back in there,
okay.
because the other way around
A
it.
bit to the camera because you know we are filmed somehow. So lying, it was that lying back, right?
I think so.
Okay.
Now it's. I'm not sure. Can you check in the
Slides a few back.
a few back upwards, upwards, upwards. Here it is.
Here it is.
Lying back. Yeah. Okay, that's right.
I know what I'm doing. I'm a good software developer.
For the second, and the second question was, are you guys hiring?
Yes, we are.
Yes, of course we are hiring. So. Yeah, actually, not yet, but maybe.
At the moment, it's mainly our Munich office which is hiring, and we just have the Munich office. We have one in Augsburg, which is close to Munich, and we're also trying to get something in Karlsruhe, but we're a very local company actually. So we try to avoid consultants traveling all the way to different cities. Yeah.
Wondering about creating the 3D stereoscopic view. Did you have to write software for that, or is it some off-the-shelf library?
So the question was, do we use an open source library for the stereoscopic view, or is it something we wrote on our own?
So this is actually on the slide for the architecture. Let's have this one. No. Here it is. So we have this camera signal, and this camera signal is then transferred via GStreamer. So that's the software we are using here.
Which is the open source software you can.
And then the display is done by the Oculus SDK. So the Oculus SDK is just displaying what we get here to the right eye, and this one to the left eye, and all the.
But the JStreamer combines it to 3D view, right?
There is no real reconstruction of the 3D image in this case, because we are just displaying the left image for the left eye and the right image for the right eye.
Yeah. The thing is, the stereoscopic camera, the how to say, the distance between the eyes, they were like for us humans. So there is no need to do any reconstruction.
Okay.
You know, so it's just take the picture from one camera, show it on the left side, on the right side, and that's it. If those cameras are, for example, aligned like in this case, then it's.
Then you would have to do.
Then you would have to do that, and on the other hand, it's complicated because the overlapping part of those two cameras are not big, and then it's a bad experience, I would say. Okay. Next question, please.
I was wondering if there are, given that there is that robot in Boston, the drunk robot, there are an implementation with machine learning in which a robot can learn by their mistakes.
Yeah,
that is an example. Yeah, the Boston drunk robot.
Actually, it is. So the question was: Is the Atlas using machine learning to learn how to walk? And actually, the answer is, in this case, no. It is just a classical algorithm which is fine-tuned exactly for the use case of keeping balance. But this is just a specific case. So there are actually libraries in which one of the Now robots is trying to walk faster than it is currently able to do. And this is done by machine learning. Yeah. It is possible, but in this specific
it's
case,
definitely possible. There are different projects on the market, for example. I forgot the name, unfortunately, where a virtual robot learns walking. And in fact, it was... you know the name? No. Okay.
I've seen that video.
You see the video? Because it was an object which had some kind of a humanoid skeleton or something like that, and it just laid around. And they implemented in the software that it gets points when it moves forward. So, and the deep learning mechanism, they just send commands to those different ankles.
Is the Google one?
No, it's it's another project.
That's not the one we have seen, but it's also quite.
But I'm quite sure that there are different
similar
projects on the market. But the idea was, I tell the software you get some bonus points if you move forward. So the algorithm just started to send some random commands to the ankles, yeah. And whenever the robot just moved a bit forward, some millimeters or centimeters, you get some points. So and after many iterations, thousands, millions of iterations, this object was able to walk somehow.
Yep. I think also in the RoboCup they are not using the standard walking mechanisms which are normally in place, which you saw right now, but they are using their own mechanisms, and some of the teams are using reinforcement learning there as well.
Cool.
When will it hit the consumer market?
This is actually when will it hit the consumer market? This is actually a question we've been asked
all the time,
quite some time now.
Yeah, very often. So,
still a long time.
Actually, a few words to the robot. So it's a commercial unit. You can buy it. There are over 6,000 sold units all over the world. So it's the standard robot when it comes to playing with robot. By the way, it's also used in education for children to learn programming or something like that. So, but regarding this project, we don't create products. We are a consulting company, but now you can take over, Mr. Partner of
But
DLG.
we try to really bring this to our customers. So our customers will not buy such a device, but they will buy part of it. Maybe they will buy maybe the streaming solution from the robot, or the VR solution, or something like this. So we
or the creativeness of the hardware hacking team, because they have innovation lab and want to have their own one. And why not asking some crazy guys who wake up in the morning and thinking, oh, I want to see the world through the eyes of a Terminator.
So the real answer is actually I don't want to take any warranty for this stuff or liability.
Okay. That's it. If you have questions,
okay.
Thank you.
Thank you.
All right, thank you very much. I have one question for you.
Oh.
Please pick a number between 1 and 11.
We should have got Alexa.
Is it
Alexa, run a number.
Tested somehow? I take 12 or -1 or?
It's between 1 and 11. The averages. All right.
8.
8. All right. Shanling Yang, you have won a ticket to GOTO conference. So I have your email address. I'll send you an email tomorrow with instructions on how you can claim your ticket. Excellent. Well, that's for the formalities. You certainly can also have some informal Q&A with our two speakers here. There's also some food and beverage left, so please feel free to stick around for a little bit longer. Thank you.
Thank you.
Ich glaube, wir haben leicht überzogen. Ja?
Leicht.
Fragen, ja.
1,5 Stunden.
How long do you guys work for the company?
12 years from now. 8 years.